standard forms of arguments. We have the valid arguments and invalid arguments. Each has 4 types. So for valid arguments, you have the direct reasoning, contrapositive reasoning, disjunctive reasoning, and transitive reasoning. Whereas in invalid arguments, you have the fallacy of converse, fallacy of inverse, misuse of disjunctive reasoning, misuse of transitive reasoning. Now, writing the symbolic form of these arguments, we have to label the first one as premise 1. The second one as premise 2. And note the 3 dots here means conclusion. So that would be the conclusion here. And then the symbolic form would be so this is like FP, then Q, and P conditional to Q. So it's like you have the statement if premise 1 and premise 2, then Q. So that's the equivalent. So let's have an example. If P, then Q, that's our first premise. The second premise would be P, and then the conclusion would be Q. So if you're going to refer back to the previous table, this is what we call the direct reasoning, and we have to show you the truth table. So if the output or the outcome would be all true, it means that's valid. Otherwise, it's invalid. Now, for all true values also, we call this as tautology from the previous section. Okay, here's the symbolic form. And then looking at the symbolic letters, you have P and Q, so that means you have 2. So using the formula that we've learned before, 2 power of 2, that's 4. So we need to create 4 possible combinations of the truth table. So in the second column, we can actually put T, and it alternates. F next, then T, then F. On the first column, that would be 2 T's, then 2 F's. And then we have to work on the inner part of the symbolic form. and that would be if P then Q. So we'll write that out here. And then we have to find out the outcome using the inputs P and Q. So looking at the values here, um, remember the truth table for conditional statement, that if you have a true for the antecedent and false for the consequent, you will get false. So that's T going to F, you'll get F. So that would be in the second row here, and the rest would be T. Okay. Next, we're going to evaluate the whole expression here, which we have that and connective. Okay. And let's extend our truth table. So we're looking at column 3, or the third column, and the first column. Okay. And we have the word and. So connective and. So the and truth table, it means all inputs would be true, and then the output would be true. So the requirements for the output to be true if all inputs are true. So we're looking at the first row here. So you have TT, so we will get a T here. And then the rest would be false. Okay, so next we have to evaluate the last part, which is the entire expression. So that entire expression goes here. This whole expression goes here. And let's evaluate that by looking at um, the fourth column and Q, which is the second. Okay, so let's look at that. And we have this operator, conditional. So it means we need to have the TF, then you will get F. So TF. Okay. We don't have one, so all of them should be T now. Okay, so that's from the truth table for conditional statement. So looking at the outcome now, you have all true values here. So this is what we call tautology. So therefore, our conclusion is valid. Okay, so that would be valid arguments, yeah, for these expressions here. And you can check that from the table that I've shown you a while ago. So that's direct reasoning, and that's under valid arguments. Okay, so let's try another example. Okay, so what we're trying to do here is we're trying to construct the truth table again and try to prove if this one is valid or not. Okay, so we will do the symbolic form, which is if premise 1, so the first premise is in the first line, and premise 2, which is Q, then the conclusion, which is P. So that's the format. And then we will make the truth table. Since you have two symbolic letters, so you have to have four possible combinations. So I'll go here TF, TF, alternates, and then two T's here, and then two F's. Next, I have to look at this term here, the inner part of the expression, which is FP, then Q. Thinking about our conditional statement, so table, you have TF to get F. So that would be here, should be F in the second row, and for the rest would be T. Okay, and then I'm looking at the next operator, which is and that would be P conditional Q, or FP then Q and Q. And let's work on that one. Okay, so in here we're looking at the third column, and then the second column of the truth table. So and means you will get a true value when all inputs are true. So that would be the first row. We'll get T there. You have TT, and then the third also row, that would be T, and the rest would be F. Okay, and then the last one is the whole thing. So this is the whole expression now, and we're going to put that on the last column here. So this goes to the last column. Okay, so we're in here, we're looking at the fourth column, and we're looking at the first column also. So evaluating that, let's look at our operator. Operator, it's conditional. It means we need a TF to get an F. So TF. So we have one, it's on the third row. So we have F here, and then the rest would be T. Okay, and here's our conclusion. So looking at this, you don't have all T or all true. It means your argument is invalid. So your answer would be invalid. So you can see that under invalid arguments also, and we call this as fallacy of the converse. Okay, so let's move on to our final example. So we have this English statements here, and we have to change this into symbolic form. The first premise says if it is cold, my motorcycle will not start. Second premise, my motorcycle started. And the conclusion, therefore, it is not cold. Okay, so first we have to assign symbolic letters here. So we're going to let P would be the first statement. It is cold. And Q would be my motorcycle started. Okay, and putting this in symbolic form, symbolic statement, we can have that the first premise would mean P conditional not Q from the first statement. So it's like if P, then not Q, because we're using not here. Okay, so Q is about the motorcycle starting. So will not start, so that's not Q. And on the second premise, that's already assigned as Q. And then the conclusion would mean there is a not there, and that is referred to P. So that should be not P. Okay. And then let's do the truth table. So we'll have P, Q, and then 4 of those. That should be 4 possible combinations because you have 2 symbolic letters, 2 power of 2, that should be 4. So we'll have TF here, then TF alternates, and then TT, and then FF on the first column. And then we're looking at not. So we're looking at this. We have a not here for Q, and we have a not here for P. So we can actually write that down as not P. And then under not P, just take the opposite of the first column, which you have F here, opposite for T, F, then T, T here. In not Q, next, you're looking at the second column, which is here, and take the opposite of that one. So you will get F, T, F, T. And then you're going to get the first premise. Okay, so let's write that out. So writing that out, that should be like this one. P, conditional not Q, and Q, and then conditional to not P. Okay, so you're looking at the first premise, then and to the second premise, and then conditional to not P, because that's the conclusion. So if the premise, the statement goes, if premise 1 and premise 2, then conclusion. So we will work on the inner part, which is this part, and that would be P. If P, then not Q. Okay, so the answer for that would be P. You're looking at the first column, and then not Q, you're looking at the fourth column. So this is conditional, so it's going to be looking at TF to get F. So TF. So we have one that's on the first row, so that would be F here, and the rest would be T. Okay, and then let's go for the next one. The next one, moving outside, we're using the symbol AND or connective AND. So that would be now if P, then not Q, and Q. Okay, so let's extend the truth table. So now you're looking at the fifth column. So let's mark that out with a different color. So that's the fifth column, and Q, which is the second one. So you're looking at that second. So fifth and second. So you're using AND connective. So the outcome would be true if all inputs would be true. So let's look for that one. Okay, so that would be the third row. So you will get T here. And then let's look at other values. So the rest would be false. Okay, so next we're going to have the whole thing, right? So the whole expression here. So that one goes to the last column. So here's the last column. And the whole expression goes here. Okay, so let's just use a different colors to make it consistent. So that's right there. So that's the whole expression here goes there. And we're using the conditional operator. So we're looking at TF again. So looking at TF, okay, from you're looking at 1, 2, 3, 4, 5, the fifth, 1, 2, 3, 4, 5, 6, sixth, the sixth column, and not P is on the third one. Again, sixth and the third column we're looking at. So we're looking at TF. Okay, so try to find that out. We have 1T on the sixth column, and we're looking at not P, the third column. So that's TT. So nothing. So all T's. And now, having all T's here, it means the argument is valid. So our answer is a valid argument. Okay, because we have all T's, and that means that's tautology. And if we have false there, then that would be invalid. So now we have all T's. That's the definition for the valid argument. Okay, so you just have to slow down and think about the different truth tables. So here you're using the conditional statement truth table and the and statement truth table.